For 4 centuries, we have been drawing a map of our solar system. We have plotted the orbits of the great gas giants, charted the paths of a million asteroids, and sent our robotic emissaries to the frozen shores of worlds billions of miles away. We believe we know our celestial neighborhood. We believe the map is complete. But in the cold, dark, and unexplored wilderness beyond Neptune, something is stirring. Out in the deep darkness, tiny frozen worlds are moving in ways they shouldn't. Their orbits are aligned, their paths are clustered, as if they are being herded by the gravity of an unseen colossal shepherd, a ghost in the machine. This is the evidence for a new, true ninth planet in our own solar system. A world perhaps 10 times the mass of Earth, lurking in the shadows, waiting to be found. Tonight, we join the hunt. We will follow the trail of gravitational breadcrumbs that lead into the outer darkness. We will draw a portrait of this phantom world and explore the violent past that may have exiled it there. Prepare yourselves for a journey to the edge of our own solar system. The search for Planet 9 begins. The hunt for Planet 9 is not the first time we have searched for a ghost in our solar system. The story of our cosmic map is a story of discovery, not just of what we can see, but of what we can infer. To understand the hunt for a planet today, we must first travel back to the 19th century. And the hunt for a planet then, the story begins with a world we already knew, Uranus. After its discovery in 1781, astronomers began to meticulously track the seventh planet's orbit. They used Newton's new and powerful law of universal gravitation to predict its path through the stars. But a problem quickly emerged. Uranus was a rebel. It refused to follow the rules. By the 1840s, it had deviated significantly from its predicted path. It was as if some unseen hand was gently nudging it, pulling it away from where it was supposed to be. The analogy is a perfect, intricate clockwork machine. If one of the gears is running slightly too fast or too slow, the conclusion is not that the laws of physics are wrong, but that there must be another, hidden gear in the machine, interacting with it. The solar system was that clockwork, and Uranus was the rogue gear. Two brilliant mathematicians, working independently, took on this mystery. In England, there was John Couch Adams, and in France, Urbain Le Verrier. They both arrived at the same stunning conclusion. The only way to explain Uranus's strange behavior was if there was another, even more distant and unknown planet whose gravity was pulling on it. This was not a vague premonition. Using nothing more than mathematics, a pen and paper, they calculated the mass of this hypothetical eighth planet, and most remarkably, they predicted its exact location in the sky. In September of 1846, Le Verrier sent his calculations to the Berlin Observatory. That very night, the German astronomer Johann Galli pointed his telescope to the location Le Verrier had specified, and there it was. A pale blue uncharted disk of light, less than 1 degree away from the predicted spot. It was the planet Neptune. It was one of the most triumphant moments in the history of science. A planet had been discovered not with a telescope, but with the sheer power of the human mind. It proved that gravity is a language. It is a force that leaves clues, fingerprints on the fabric of space-time. It showed us that we can find a world not by seeing it, but by seeing its shadow, by witnessing the subtle gravitational whispers it imparts to its neighbors. This is the fundamental principle at the heart of our modern hunt. We are not looking for a planet. We are looking for its shadow. And the crime scene is the dark, frozen frontier of our own solar system. For most of human history, our conception of the solar system ended with the majestic, distant orbit of Neptune. We knew of the rocky inner planets, the great gas and ice giants, and we believed that beyond them lay only the empty interstellar void. We were wrong. Beginning in the late 20th century, we discovered that our solar system has a third great kingdom, a vast, dark, and frozen realm of countless tiny worlds. This is the Kuiper Belt. The Kuiper Belt is a colossal, donut-shaped ring of icy bodies, a celestial debris field left over from the formation of the solar system. It begins just beyond the orbit of Neptune, at about 30 times the distance from the Sun to the Earth, and stretches out to about 50 times that distance. The analogy is a great city. The inner rocky planets are the dense, brightly lit downtown core. The gas giants are the sprawling, majestic suburbs. The Kuiper Belt is the vast, dark, and sparsely populated wilderness that surrounds the city limits, filled with forgotten relics and the raw materials from which the city was built. The first and most famous resident of this wilderness to be discovered was, of course, Pluto, found in 1930. For decades, it was considered a lonely oddball, a strange, small planet at the edge of the solar system. We now know it was not an outlier. It was simply the first clue, the first hint of the vast population of worlds that lay beyond. Since the 1990s, we have discovered thousands of these Kuiper Belt objects, or KBOs. They range in size from small kilometer-wide chunks of ice to dwarf planets like Eris, Meki, and Haumea, worlds large enough to be spherical. We now believe there are over 100,000 KBOs larger than 60 miles in diameter, and perhaps trillions of smaller, comet-like objects. This is the great frozen reservoir of our solar system, and for the most part, the objects within it behave as they should. Their orbits are shaped and controlled by the immense gravity of the last great planet, Neptune. They are like a flock of sheep dutifully herded by the gravitational crook of this final giant. But as our telescopes peered deeper into this darkness, we began to find objects that were not part of this flock. We began to find strays, to worlds on orbits so vast and so strange, they were far beyond the gravitational reach of Neptune. They were the first hints that something else, something powerful and unseen, was acting as another shepherd in the far, dark fields of the cosmos. And the first of these great cosmic strays was a world named Sedna. In the year 2003, a team of astronomers including Mike Brown, Chad Trujillo, and David Rabinowitz discovered an object that defied all explanation. It was a moderately large dwarf planet, perhaps 600 miles in diameter, with a distinctly reddish hue, but it was its orbit that was so shocking. They named it Sedna, after the Inuit goddess of the sea, and it was a world that appeared to be lost in the middle of a vast cosmic ocean. To understand Sedna's strangeness, we need to understand a concept called the perihelion. It is the point in a celestial body's orbit where it comes closest to the sun. The objects in the main Kuiper belt have perihelia that bring them relatively close to the orbit of Neptune, which is how Neptune is able to control them. But Sedna was different. At its closest point, its perihelion, Sedna is 76 times further from the sun than the Earth is. That is more than twice the distance to Neptune. It is so far away that Neptune's gravity has no meaningful effect on it. And at its most distant point, its aphelion, it swings out to a staggering distance of nearly 1,000 times the Earth-Sun distance. Its journey around the sun is not a circle, but a great, elongated, 11,000-year loop through the darkness. This was a profound puzzle. The analogy is finding a lone, stationary boat in the absolute middle of the Pacific Ocean. The boat has no engine, no sails, and no oars. It is not close enough to any continent to have been pushed by the tides. So how did it get there? You are forced to conclude that some other powerful, unseen force must have brought it there and left it. Sedna is that boat. Its orbit could not be explained by the known architecture of the solar system. It was the first member of a new class of object, what we now call the detached objects, or the inner Oort cloud. It was a clue that our map was fundamentally incomplete. What could have put Sedna on such a strange path? For years, astronomers proposed various theories. Perhaps a passing star, long ago in the sun's youth, gravitationally kicked it into this orbit. Perhaps it was captured from another star system. Or perhaps there was another unseen planet in our own solar system, a massive body orbiting far beyond Neptune, whose gravity had flung Sedna into its strange, lonely exile. At the time, it was just one object, one data point, a tantalizing but unproven idea. But then, we found more. And one strange object became a conspiracy. For over a decade, Sedna remained a lonely curiosity, a single strange clue in a cosmic cold case. But the hunt continued. Astronomers pushed our technology to its limits, searching for ever fainter, ever more distant objects in the solar system's dark frontier. And they began to find more of these detached objects, more worlds on strange Neptune-defying orbits. And in 2016, two of those astronomers, Mike Brown and Konstantin Batygin at Caltech, noticed something that would change the course of planetary science forever. They were not just looking at the orbits themselves, they were looking for a pattern. They decided to focus only on the most stable, most distant objects, the ones whose orbits were so vast, they were completely immune to the gravitational meddling of Neptune. They found 6 of them, and what they saw was almost impossible. These 6 objects, including Sedna, all had highly elliptical orbits, like Sedna's. But there was a startling similarity: the long axes of their orbits, the direction of their stretched out ellipses, all pointed in roughly the same direction in space. They were all tilted in a similar way relative to the plane of the solar system. It was as if these 6 independent, lonely worlds were all marching in formation. The analogy is a detective who finds 6 different compasses at 6 different crime scenes miles apart. By all rights, these compasses should be pointing north, but the detective finds that all 6 of them are pointing in the same direction, say to the southeast. The logical conclusion is not that all 6 compasses just happen to break in the exact same way by random chance. The logical conclusion is that there must be a powerful hidden magnet somewhere to the southeast that is pulling the needle of every single one of those compasses into alignment. This is the evidence for Planet 9. The 6 distant objects are the compasses. Their clustered orbits are the needles all pointing in the same direction. And the hypothetical Planet 9 is that powerful unseen magnet. Brown and Badigan calculated the odds of this alignment happening purely by chance. The number they arrived at was just 0.007%, or about 1 in 15,000. It was statistically possible that they had just witnessed the astronomical equivalent of being dealt a royal flush. But it was far more likely that they had just uncovered the gravitational fingerprint of a hidden massive world. The solar system was no longer a clockwork of 8 gears. The ghost in the machine was beginning to take shape, and the detectives now had enough evidence to issue a warrant. The evidence was compelling. A half dozen of the most distant objects in our solar system, marching in a formation that defied probability. But how could a single unseen planet lurking hundreds of billions of miles away in the darkness exert such a powerful and organizing influence? The answer lies in the patient, subtle, and inescapable power of gravity, acting over immense spans of time. The hypothetical Planet 9 is a gravitational shepherd. The theory proposed by Brown and Badigan is one of celestial architecture. They imagine a 9th planet, about 5 to 10 times the mass of the Earth, in a vast elliptical orbit that is anti-aligned with the orbits of our 6 small objects. This means that when Planet 9 is at its closest point to the Sun, our 6 small worlds are at their furthest, and vice versa. The analogy is a large, slow-moving ship creating a powerful, persistent wake in a wide harbor. In that harbor are dozens of small drifting rowboats. Over a very long time, the gentle but constant push and pull of the ship's wake will organize the rowboats. It will nudge them and turn them until they all settle into a stable configuration, bobbing in the water in a similar alignment, a pattern dictated by the passage of the unseen ship. Planet 9 is that ship. Its immense gravitational influence is the wake, and the 6 small KBOs are the rowboats, organized by its passage over millions and millions of years. This process is called secular resonance. It is not a quick, violent interaction. It is a slow gravitational conversation that takes place over eons. Planet 9, on its vast 20,000-year orbit, would exert a tiny rhythmic gravitational tug on these smaller worlds. Over millions of years, these tiny tugs add up. They shepherd the orbits of the smaller bodies, pushing them into this stable, clustered, anti-aligned configuration, the one of lowest energy, the one that prevents them from ever having a close orbit disrupting encounter with the giant planet. But the theory made another, even more startling prediction. This gravitational shepherding should do more than just cluster the orbits. It should also kick some of them into completely different, extreme trajectories. Specifically, it should produce a population of objects whose orbits are tilted almost perpendicular to the plane of the rest of the solar system. When Brown and Badigan published their theory, no such objects were known. It was a bold, falsifiable prediction. If their model was correct, these objects had to be out there. And in the years since, astronomers have found them. A handful of KBOs, like the object nicknamed Drac, have been discovered on these bizarre, high-inclination orbits, exactly where the theory predicted they should be. The ghost was not just organizing the furniture, it was actively throwing some of it out the window. The gravitational fingerprints are there. At the witnesses, the 6 distant worlds, are all telling the same story. The theory has made successful predictions. The case for a hidden world is strong, so based on the evidence, what can we say about our suspect? We can begin to draw a portrait of the celestial ghost. We can describe the nature of Planet 9. First, its mass. By analyzing the amount of gravitational force required to keep the orbits of those distant KBOs clustered, we can estimate its weight. The calculations suggest that Planet 9 must be somewhere between 5 and 10 times the mass of the Earth. This makes it a substantial world. It would be the fifth largest planet in our solar system, after the four great gas and ice giants. It is not a small icy dwarf like Pluto. It is a true bona fide planet, a world with enough mass to dominate its orbital neighborhood and to sculpt the very architecture of the outer solar system. Second, its nature. What would a world of this mass be made of? It is almost certainly not a rocky terrestrial planet like Earth. It is too massive. A world of 5 to 10 Earth masses would have enough gravity to hold onto a thick primordial atmosphere of hydrogen and helium gas, the raw material from which the solar system was born. This makes Planet 9 a smaller version of Neptune or Uranus, a true ice giant. It would likely have a solid core of rock and ice, surrounded by a thick, slushy mantle of water, methane, and ammonia, all wrapped in a deep, dark, and incredibly cold atmosphere of hydrogen and helium. Third, its orbit. This is perhaps its most dramatic feature. The simulations show that Planet 9 must be on a vast, highly elliptical orbit. Its closest approach to the Sun, its perihelion, would be about 200 to 300 times the Earth-Sun distance, a region of space that places it far beyond the main Kuiper belt. But at its most distant, its aphelion, it could swing out to a staggering 600, or perhaps even 1,200, times the Earth-Sun distance. A single journey around the Sun, a single year on Planet 9, would take between 10,000 and 20,000 Earth years. And finally, its appearance. From its surface, the Sun would appear as little more than an intensely brilliant, unwinking star, casting a pale, eerie light about as bright as our full moon. The temperature on this world would be unimaginably cold, likely around minus 375 degrees Fahrenheit or minus 226 Celsius. It is a world of permanent frozen twilight. This is the portrait of our ghost, a dark, cold ice giant, 5 to 10 times the mass of Earth, on a vast 20,000-year journey through the darkness. The profile is clear, but it raises an even deeper question. A planet of this size has no business living in the frozen exile of the far solar system. How did it get there? We have a portrait of our suspect, a massive, dark, and lonely ice giant, exiled to the cold outer fringes of our solar system. But the portrait raises a tantalizing question. How did it get there? The modern solar system is a place of relative peace and order, but its youth was a time of unimaginable chaos and violence. The origin story of Planet 9 is likely written in the language of this ancient planetary brawl. There are two leading hypotheses for its mysterious past. The first, and perhaps most likely, is that Planet 9 is a native of our solar system. It is a lost fifth giant. The theory of planetary formation tells us that the early solar system was not born with the neat, orderly set of planets we see today. It was likely a much more crowded and chaotic place, with dozens of large planetary embryos jostling for position. It is possible that our solar system did not form 4 gas giant cores, but 5. In this scenario, this fifth giant planet, Planet 9, would have formed much closer to the Sun, in the same neighborhood as Jupiter, Saturn, Uranus, and Neptune. But in the gravitational chaos of the early solar system, it had a close encounter with one of its larger siblings, most likely the bully of the playground, Jupiter. The analogy is a cosmic game of billiards. The fifth giant was a ball that got too close to the massive Jupiter ball. The gravitational interaction would have acted like a powerful slingshot, flinging the smaller planet out of the stable, inner region of the solar system and into its current vast and elliptical orbit. In this story, Planet 9 is a true exile, a native prince banished from the inner court of the Sun and forced to wander the dark wilderness forever. This scenario is supported by simulations that show this kind of ejection was a common, and perhaps even probable, event in the formation of planetary systems. The second hypothesis is even more dramatic. In this story, Planet 9 is not a native. It is an imposter. It is a captured wanderer. Our Sun was likely born in a dense cluster of other stars. This means that in its youth, other star systems were passing by much more closely than they do today. It is possible that Planet 9 was a rogue planet, a free-floating world that had been ejected from its own original solar system and was wandering cold and alone through interstellar space. In this scenario, as its original star passed by our own, the Sun's powerful gravity could have stolen this rogue planet, capturing it into a wide, stable orbit. It is a story of cosmic adoption, the Sun taking in an orphan from another star. If this is true, Then studying Planet 9 would give us our first ever opportunity to study a planet from another star system up close. It would be an alien world in our own backyard. Whatever its true origin, its story is a powerful reminder that our solar system's past was far more violent and chaotic than its peaceful present would suggest. The evidence is compelling. The calculations are elegant. The theories of its origin are tantalizing. But a hypothesis, no matter how beautiful, is not a discovery. A ghost is not real until you can see it with your own eyes. The final and most difficult step in our story is the hunt itself. How do you find a single, dark, and impossibly distant world hiding in the vast, star-filled expanse of the cosmos? The challenge is almost beyond comprehension. Planet 9, at its predicted distance, would be astronomically faint. It is so far from the Sun that the light it reflects is incredibly feeble. Depending on its exact size and location, it is predicted to be somewhere between 10,000 and 1,000,000 times fainter than the dimmest object you can see with your naked eye. This means it can only be detected by the largest and most sensitive telescopes on Earth. But its faintness is only the first problem. The second is its motion. Because it is so far away, its movement against the background of the fixed distant stars is agonizingly slow. It is a cosmic snail crawling across the heavens. This makes it incredibly difficult to distinguish from the billions of other stationary points of light. So how do you find it? The analogy is trying to find a single, specific black grain of sand that is moving at a snail's pace on a beach that is thousands of miles wide and covered in glittering diamonds. The method is one of brute force and infinite patience. Astronomers must survey vast patches of the sky, night after night. They use powerful telescopes, like the Subaru telescope in Hawaii, to take deep, high-resolution images of a specific region of the sky. Then, they come back a few hours, or a few days, later and take another image of the exact same spot. They then use powerful computers to compare the two images, digitally subtracting one from the other. If everything in the image is a distant star or galaxy, the two pictures will be identical, and the subtraction will result in a blank black frame. But if one of those tiny points of light is a hidden planet in our own solar system, it will have moved, ever so slightly, between the two exposures. In the subtracted image, it will appear as a single lonely point of light, a tiny ghost that has betrayed its own presence by its motion. This is the painstaking work of the hunt. It involves sifting through petabytes of data, filtering out false positives from asteroids and cosmic rays, all in the search for one single consistent moving object that matches the profile of our phantom. The search area is vast, and the object is faint, but a new generation of telescopes, like the Vera C. Rubin Observatory currently being built in Chile, will soon come online. This observatory will survey the entire visible sky every few nights, a fire hose of data that will be perfectly suited to this hunt. Many astronomers believe that if Planet 9 is out there, the Rubin Observatory will find it. The hunt is on, and the ghost, after a century of hiding, may not have much longer to hide. For years, the hunt continues. Thousands of nights, terabytes of data, a meticulous, patient search for a single moving needle in a cosmic haystack. And then, one day it happens. An automated computer program flags a candidate. Astronomers, with bated breath, train their instruments on it, tracking it, confirming its orbit. The calculations are checked and rechecked, and the announcement is made. The ghost is real. We have found Planet 9. What would that moment mean? It would be a revelation that would echo through history. For the first time since the discovery of Neptune in 1846, the map of our solar system would have to be redrawn. We would wake up in a solar system that was suddenly fundamentally larger and more mysterious than the one we had known the day before. The analogy is that of an ancient explorer who believes they have mapped the entire coastline of the known world, only to see the mists part one morning to reveal an entirely new massive continent on the horizon. The world is not what they thought it was. The map is incomplete. The discovery would ignite a new golden age of planetary science. Textbooks would be rewritten. Our intricate clockwork models of the solar system's formation and evolution would have to be revised to account for this new massive player. The story of our solar system's violent youth, the story of exiled and wandering giants, would move from the realm of theory into the pages of history, and it would have a name. What would we call this new world? The International Astronomical Union would be tasked with choosing a name from the mythologies of the world. a name to sit alongside Jupiter, Mars, Venus, and Neptune. It would be a name that would be taught to every school child, a new word in the vocabulary of our cosmic home. But most importantly, we would have a new destination, a new frontier. The discovery of Planet 9 would immediately make it one of the most compelling targets for future exploration. NASA and other space agencies would begin to dream of sending a probe, a new Voyager, on the long, decades-long journey into the outer darkness. To see this world up close, to measure its atmosphere, to study its composition, and to search for the one thing that a world this large would almost certainly possess, its own family of moons. The discovery of a new planet would not be the discovery of a single world, but of an entirely new system. If Planet 9 is a true ice giant, a smaller sibling to Uranus and Neptune, then it would not be traveling alone. A world of 5 to 10 Earth masses would possess a powerful gravitational field, easily capable of capturing and holding on to its own entourage of moons. The discovery of Planet 9 would, in all likelihood, be the discovery of a new miniature solar system, orbiting in the distant dark. What might these moons be like? They would be worlds born of the Kuiper Belt, captured chunks of ice and rock, their surfaces ancient and battered by eons of cosmic radiation. But the most tantalizing possibility lies not on their surface, but deep within their interiors. We have seen at Jupiter and Saturn that even a small icy moon can be transformed by the gravity of its parent planet. The constant stretching and squeezing of tidal forces can generate enough friction to heat the interior of a moon, melting its ice to create a vast liquid water ocean hidden beneath a protective frozen shell. Worlds like Europa and Enceladus are prime candidates for life beyond Earth, precisely because of these hidden tidally heated oceans. Could Planet 9 host such worlds? The analogy is a tiny frozen rock held in a giant's powerful rhythmic grip. As the giant constantly squeezes and relaxes its grip, the friction generates a deep internal warmth, melting the rock's core into a liquid state. Planet 9 would be that giant, and its moons would be those frozen rocks. The heat would not come from the distant, feeble sun, but from the gravitational kneading of their parent planet. In the unimaginable cold and darkness of the outer solar system, Planet 9 could be presiding over a kingdom of ocean worlds, moons with more liquid water than all the oceans of Earth combined, their depths warmed by tidal friction and potentially hosting hydrothermal vents, the very same kind of environment where many scientists believe life on Earth first began. This is, of course, a deeply speculative idea, but it is based on the physics we have observed in our own solar system. It raises a breathtaking possibility that the discovery of a single dark and lonely planet at the edge of our solar system could simultaneously reveal the existence of a whole new class of potentially habitable environments. The hunt for Planet 9 is not just a hunt for a planet, it is a hunt for new possibilities, for new arenas in which the chemistry of life might take hold. But what if the hunt is based on a false premise? What if the evidence is leading us not to a new planet, but to a new conclusion? The evidence for Planet 9 is tantalizing. The clustered orbits, the successful predictions. It tells a compelling and elegant story. But in science, a good story is not enough. Every hypothesis must be subjected to rigorous scrutiny. And the case for Planet 9 is not without its powerful counterarguments. We must now consider the possibility that we are not hunting a planet, but chasing a phantom, an illusion born from our own incomplete data. The single greatest argument against Planet 9 is the argument of observational bias. This idea suggests that the strange clustering of the 6 distant objects is not a real physical phenomenon, but a trick of the light, a product of where and how we have been looking. The analogy is searching for your lost keys in a vast, dark field at night. Using only a small flashlight, you sweep your beam across the ground, and you happen to find a small cluster of coins in the circle of your light. You might be tempted to conclude that there is something special about that spot, that some force has gathered the coins there. But the far more likely explanation is that there are coins scattered all over the field, and you have simply not yet pointed your flashlight in the right places to find them. Our telescopes are that flashlight. The night sky is vast, and the star fields of our own Milky Way create a wide swath of the sky that is incredibly dense and difficult to search for faint, distant objects. As a result, many of our deep solar system surveys have intentionally avoided looking there. They have pointed their flashlights at the darker, emptier parts of the field. The fact that we have found a cluster of objects in these regions might not mean there is a planet hurting them. It might just mean that is where we have been looking. If we were to survey the entire sky, the cluster might dissolve into a random uniform distribution. There are other, more complex theories as well. One idea is that there is no single large planet, but that the collective gravity of the thousands of smaller, undiscovered objects in the scattered disk of the Kuiper Belt could, over billions of years, organize themselves to create the clustering we see. This is the theory of a gravitational conspiracy, where the flock is herding itself, without the need for a shepherd. These are powerful, scientifically valid arguments. They remind us that the evidence, while compelling, is still circumstantial. We have not seen the planet. We have only seen its shadow. And until we do, we must remain open to the humbling possibility that we have been tricked by the darkness, and that the ghost in the machine is a reflection of our own limited view. The debate is set. On one side, a powerful, elegant hypothesis that explains a host of strange phenomena in the outer solar system. On the other, the skeptical, cautious voice of science, reminding us of the dangers of incomplete data and the seductive allure of a good story. How will this debate be settled? The arguments will not be won with better calculations or more sophisticated simulations. They will be won with light. The final verdict will be delivered by a new generation of telescopes, a new set of eyes on the universe, powerful enough to either capture our ghost or prove it does not exist. The most powerful of these new eyes is the Vera C. Rubin Observatory, currently nearing completion on a mountaintop in the Chilean Andes. It is a machine designed to map the cosmos on an unprecedented scale. Its goal is a monumental undertaking called the Legacy Survey of Space and Time, or LSST. For 10 years, the Rubin Observatory will survey the entire southern sky over and over again, once every few nights. The analogy is moving from a single, handheld flashlight to installing colossal, stadium-style floodlights over the entire field. With the Rubin Observatory, we will no longer be searching in isolated patches. We will be illuminating the entire landscape, all at once. This survey will be perfectly suited to settling the Planet 9 debate once and for all. First, it will eliminate the problem of observational bias. By mapping the entire southern sky, it will find thousands of new Kuiper Belt objects in every direction. If the strange clustering of orbits is just an illusion, the Rubin Observatory will prove it. The Gang of Six will be drowned in a sea of new discoveries, their pattern revealed as a statistical fluke. This would be the definitive death of the Planet 9 hypothesis as we know it. But if the hypothesis is correct, the Rubin Observatory is our single greatest tool for finding the planet itself. Its incredible sensitivity and its rapid repeating survey of the sky make it the ultimate phantom hunter. It will generate a motion picture of the cosmos, allowing us to spot the slow, deliberate movement of a distant planet against the background of the stars with a precision we have never before achieved. If Planet 9 exists, and if it is in the southern sky, most astronomers believe the Rubin Observatory will find it within the first few years of its operation. The verdict of the sky is coming. The Rubin Observatory, and other powerful telescopes, will soon give us an answer. Either they will present us with a photograph of a new ninth planet, a discovery for the ages, or they will present us with an even deeper mystery, a solar system whose outer edges are shaped by a force that we do not yet understand. We began our journey on the trail of a ghost. We followed the faint gravitational whispers of tiny frozen worlds deep in the darkness beyond Neptune. We built a portrait of our quarry, a massive hidden planet, a lost giant, shaping our solar system from the shadows. We have explored its violent origins, and we have joined the patient, ongoing hunt to find it. But our journey, like all journeys into the unknown, ends not with a simple answer, but with a deeper and more profound question. Whether Planet 9 is ultimately discovered or not, the hunt for it has already been a spectacular success. The search has pushed our technology to its absolute limits. It has forced us to create new maps of our own celestial backyard, revealing a menagerie of strange and wonderful new worlds that we never knew existed. It has forced us to re-examine the violent, chaotic history of our solar system's birth. The ghost, whether real or imagined, has been a brilliant and productive guide, leading us deeper into the darkness than we have ever gone before. And this is the true nature of scientific discovery. It is not just about finding the answers, it is about learning to ask better questions. If Planet 9 is found, it will be a discovery that reshapes our understanding of our place in the cosmos. It will prove that our solar system is not a finished, static museum, but a living, evolving system with secrets still to be revealed. It will give us a new world to explore, a new story to tell, And if Planet 9 is not found, if the great surveys come up empty and the orbital clustering is proven to be an illusion, the mystery does not go away, it deepens. It would mean that there is another force at play in the outer solar system, some new gravitational phenomenon, some new aspect of celestial mechanics that we do not yet understand. The ghost would remain, but it would have taken on a new and even more mysterious form. The hunt for Planet 9 is more than a search for a single world. It is a testament to the power of human curiosity. It is the story of how we listen to the silence, how we read the invisible language of gravity, and how we are constantly, relentlessly, pushing the boundaries of our knowledge ever deeper into the great, beautiful, and unknown darkness.